Hey everybody, we're back here, Virtual Geometry, Mr. Crofton here, walking you through something. We're going into the third dimension now. So we're going into 3D shapes, talking volume and surface area of prisms and cylinders. So, to get started here, we're going to look at a prism, okay? Prisms are 3D shapes that have two bases that I'm highlighting right now that are parallel to each other and congruent to each other, and they're connected by corresponding vertices. That's the formal definition, right? The way we find the volume of one of these prisms is you find this base here. It's all about the base. Okay? I was not trying to make a song reference, but it's all about the area of that base. Okay? Find the area of the base, and then you simply multiply it. And think of that as like the bottom layer, right? And you multiply it by, what I'm tracing in red here, is the number of layers there are, which is the height. One heads up, if this prism was on its side, that height is really kind of horizontal. So it's the distance between your two bases. Okay. Surface area gets a little trickier. Again, we've got that same area of the base. The one part that we're adding that's a little different here is, let's go blue. This little PB is the perimeter of the base. Okay? So what you're doing is you're finding the perimeter of that base and you're multiplying it by the height yet again. So you're kind of finding that whole lateral area. Let's apply it in this problem here. Okay, first one out, basic rectangular prism. So I'm going to, again, trace my base. Easiest way, I always go through, trace my base first. I know it's going to correspond with this top one. So to find volume, the area of my base is a 12 by 5 rectangle, so 60 centimeters squared, technically, right? To find volume, though, I take that 60 and I multiply it by the height, the distance between the two bases, which is 8, to get me a whopping total of 480, centimeters cubed. Okay. Volume's nice and easy. Find that bottom layer basically multiplied by the number of layers. I like thinking of it like that. Surface area then's a little trickier, but we got this formula, so we're going to use it, okay? I'm going to go straight up and plug it in. All right. 2 times the area of my base, and guess what? I already found that. So this is going to be an easy little part I can transfer over. Plus the perimeter of my base. Now, for that, I got to think through this. This is a rectangle that's 12 by 5. 12 by 5. Okay, that means this is 12. That means this is 5. Getting a perimeter of, what does that get me? 34? Looks good to me. 34 times, now my height is that same height I used over here, which is 8. Okay. I'm going to simplify both these things out a little like separately. So 2 times 60 is 120 plus 34 times 8 gets me 390. Oh, no. 272. For a whopping total of 392 units squared. Boom. Got my 2 answers. All right. Now, you might be thinking, hey, I heard some different formulas for surface area and volume before. Yeah, you're absolutely right. And that would work for this shape, but the reason why we don't use that is because we've got shapes like this also, right? We've got triangular prisms, trapezoidal prisms, all kinds of prisms, all right? So go about it the same way. Now, this one is going to be a little trickier. So what I'm going to do, and I suggest you do, base is the first thing we always look at, right? It's all about base. I'm going to draw that. I just rotated it about 45 degrees or so. I know this side is going to correspond with this, so I'm going to draw 15 right here. Let's see now. I know this side is the same as this, so I know this right here is 12. I don't know this third side of it, though. But if you know your Pythagorean triples, it's certainly going to help out. If not, you can do, because it's a right triangle, a squared plus 12 squared equals 15 squared. And if you solve that Pythagorean theorem out, you would get an answer of a equals 9. So it's 9. All right. Now that helps me a lot because now I got to find my volume. And first to find that, the area of my base My base is a triangle, so it's 1/2 the base, which is 9, times the height, which is 12. Okay? Which gets me a total of 54. All right. Finding volume, I take that 54, the area of that base, and multiply it by the height, which is 10, to get me 540 centimeters cubed. Perfect. Okay. Now let's get on to surface area. So looking back at surface area, I want to again look at that base, and I already found the area. So surface area equals 2 times the base area, which is 54, plus, now I need the perimeter of the base, but I already have all the sides kind of labeled individually. Let's see. Nope. Come on. There it is. All right, this was my triangle. Numbers didn't follow, but I got 12, 15, and 9. Okay? Add those three things up, and it gets me a perimeter of 36. Cool. So 36 times the height, which is 10. All right, simplifying individually, 108 plus 360. Going to get me a grand total of 468, centimeters squared. Boom. Cool. So those are my prisms, all right? It's all coming back to focusing on, I'm going to clean this up a little bit, focusing on that base that we talked about, all right? Find the area of that, and everything's going to build off of that. So trace your base, go from there, all right? So you might be wondering, why do I need to know this, that kind of thing. Question is, what would happen if you don't learn about volume and surface area? You want to know? You'd go to Prism. It's like jail, prison. Yeah, it's pretty good. So another question, being more serious this time. What about if you cut the prism in half? What's going to happen? All the prisoners escape. Oh, God, that's good. That's a good pun. All right. Anyways, moving on. We've got volume and surface area of cylinders now. This is exactly the same thing, right? This pi r squared, it's basically a circular prism, right? This is the area of the circular base. I apologize, my poor handwriting right now, but pi r squared is basically my big B times h. It's the same idea, right? Surface area then, pi r squared, again we see 2b plus 2 pi r is the circumference, which is basically the perimeter times the height. So really, it's the exact same formula that we're going through here, all right? It's just in terms of a circle. So let's try it out on this basic example here. Let's see. Volume equals, so I'm first going to find the area of my base. And look at me, always tracing my base. So the area of my base is pi 4 squared, which I'm just going to leave as 16 pi. That's my big B, basically, right? That's this. Oops. This. Cool. I got that. Basically, top layer, multiply it by the number of layers. So 16 pi times 9 gets me, 144? 144 pi meters cubed. Boom. So notice, I'm just going to leave it in terms of pi, just because it works out to be a nice even number with a pi on it. You could multiply it out and get a decimal version as well. But let's keep going. All right. 2 pi, my radius is 4 squared, plus 2 pi, my radius is still 4, my height is 9. All right. All that stuff together, I'm going to simplify each of these individually. That 4 squared is 16 times 2 gets me 32 pi. Plus 2 times 4 is 8 times 9 is 72. I add those two together to get 104 pi meters squared is my surface area. So just plugging through this formula, you're going to get there. All right? Okay. Now we're going to apply it. We got our surface area, where we got everything with our prisms and cylinders. We're going to apply it. So, real situation here. Trying to think outside the box, a popular soda company decides to market prisms of soda instead of the traditional can. They claim that the Prism fits easier into your refrigerator and even contains more soda. The cans have a rectangular base, 6 by 10, and are 10 centimeters tall. I'm going to draw that right now while I'm thinking on it. It's got a 6 by 10 base and is 15 centimeters tall. Notice my picture's not great, but I know what it means. That's all that matters. The traditional can is cylindrical with a diameter of 10 centimeters. Diameter is 10 and 12 centimeters tall. If the two products cost the same, what's the better deal? In other words, what's giving you more soda? So you should think surface area, volume. You got to find volume because you got to know how much soda is going to fit inside of it. That's what I care about. So I first want to find, let's go red. The area of my base, which is this down here, okay? The area of that is 6 times 10, or 60. Awesome. To find the total volume, I do 60 times 15, which gets me 900 centimeters cubic centimeters of soda. That's a lot of soda. All right. Let's see, though, what it is for the can. All right. So my volume is the area of my base, which is pi r squared, and my radius is 5. So pi 5 squared, which gets me 25 pi. That is the area of my base. Multiply it by the number of layers, basically. The height of it, 25 pi times 12 gets me 300 pi. And you might look at that and be like, oh, what's bigger? You can't tell because there's pi in there, so what you have to do is you have to multiply it out, and you get approximately 942.5 cubic centimeters. So the question of which one's the better deal, it is your cylinder, the traditional can of soda. It's just going to hold more soda. I mean, unless you like the crazy looking rectangular Prism can, in which case you'd be a little crazy. All right, last one we're going to do here. So we use volume on that first one. There's another application problem. We got to figure out what we need to use. You want to paint the walls of your room, not the ceiling or floor. Okay. If your room is 20 feet wide, 25 feet long, and 10 feet high. All right. So look at the room you're in right now. Compare. Okay. Think of these same dimensions applying to your room, assuming it's a rectangular base. 20 feet wide, 25 feet long, and 10 feet high. You want to paint, but you're not going to paint your carpet, right? You're not going to paint the floor. You're not going to paint the ceiling. So what you need to find is something called the lateral area. So to do this, I'm going to break it down and find each part individually. All right. Oh, by the way, it's surface area because we're not filling the room with paint. We're just covering the sides of it, right? So I want to find this rectangle first. It is 20 by 10. Okay. 20 times 10 gets me 200. That is the front. Being the smart person that I am, I realized that that back is exactly the same. So I'm going to take that times 2 to give me 400. All right, that is the front and back. Next thing I need to include are the sides, right? So looking at the right, I've got a rectangle that is 10 by 25. So 10 times 25 equals 250. And again, being a genius that I am, I realized that the left is also the same. So times 2, 500. Finding the total area that I'm going to paint. And remember, I'm not just plugging the formula. I can tweak the formula, but I'm not going to plug it in because it doesn't necessarily apply. I'm not painting the ceiling. I'm not painting the floor. You could find the total surface area and subtract them. I'm choosing to go this way. I take that 400, I take that 500, I add them together to get 900. And I realize I gotta go to the store and figure out how much paint I want to buy. Each bucket of paint covers 400 square feet. So, coming over here, 900 divided by 400 gets me 2.25. But if you're gonna go in, this is square feet, this is square feet. If you're going to go into the store and ask for 2.25 buckets of paint, they're going to laugh at you and tell you to get the heck out. So you need 3 cans of paint to make sure that you can cover everything and not have too much left over. All right, good stuff, guys. Good work. Keep up the positive geometry work. I'll see you out there.